Today's lesson is on multiplying radicals. So get out your notes, your notebook, and let's work some problems. All right, you can see that we have the product property of square roots. And the product property of square roots states that if you have the square root of a times the square root of b, you can just multiply a and b together and put them both under the radical. And that's what we're going to be doing. So here are the steps to multiplying radicals. To multiply radicals, multiply the coefficients together on the outside, then multiply the radicands together on the inside, and then you get to simplify completely. And then we must remember these things. A radical is in simplest form if there are no perfect square factors other than 1 in the radicand, there are no fractions in the radicand, and no radicals are in the denominator of a fraction. All right, so let's get started. All right, so for number 1, we're going to multiply the two radicands together, and when we do, we would get radical 75. So then we have to simplify. So simplify, remember you're looking for the largest perfect square that is a factor of this number. And we know that the square root of 75 is the same thing as the square root of 25 times 3. Well, we can take the square root of 25 as 5 and multiply that times the square root of 3, which we can't take that is not a perfect square. So your answer would be 5 radical 3. Okay, on my next one, I've got 5 times 35. So I'm going to multiply that together, and I know that 5 times 35 is 175. So now to simplify that, again, I'm looking for the largest perfect square that is a factor of 175. And I know that 25 times 7 gives me 175. Then that means that I have to take the square root of 25, and the square root of 25 is 5. And I can't take the square root of 7, so I leave it there. So my answer is 5 radical 7. So on number 3, remember you're going to multiply the coefficients together. So you're going to multiply the 2 times the 4, and then you're going to multiply the radicands together, which is 3 times 24. So 2 times 4 gives me 8. So this is 2 times 4. And then I multiply inside the radicand to get 3 times 24. Well, 3 times 4 is 12, and 3 times 2 is 6, add 1, so I get 72. So now I need to simplify the square root of 72. And I'm looking for the largest perfect square that is a factor or goes into 72. And I know that the square root of 36, so if you do 36 times 2, you would get 72. Now you might be tempted to do 8 times 9, but that's not going to work. You'll have more work to do if you do that. All right, so now to simplify that, I'm going to take 8 times the square root of 36, which is 6, and then leave the 2 inside the radical. So 6 times 8 is 48, and my answer is 48 radical 2. Okay, so let's go to number 4. And you can see that you're going to need to write the problem down, obviously. And now we're going to remember to multiply the coefficients together and multiply the radicands together. Well, here you can see there's no coefficient in front of this radical. So when you don't have a coefficient, that means you have a 1. So I'm going to multiply this 1 times that 2 to get 2. And then I'm going to multiply everything inside the radicand. 2 times 18 is 36. So that's 2 times 18. And then x squared times x cubed gives me x5. Remember, you add the exponents. And then y times y gives me y squared. And now I need to simplify everything and take square roots. Okay, so I have a 2. Now if I take the square root of 36, then I'm going to take the square root of x5, and then I'm going to take the square root of y squared. So I can break everything down, all the factors down, and take the square root of them. So this would be 2 times the square root of 36 is 6. Now x5 needs to be broken down into the largest perfect square, which would be x4 times x, and I need to take the square root of x to the fourth, which is x squared, and then the square root of x, which I have to leave under the radical. Then I'm going to take the square root of the y squared, which is just y. Now remember, I put everything together by multiplying all of the numbers and letters or variables that are not in the radical, which is 12x squared y, and then I have to leave the radical x, and that would be my answer. Okay, so on the next problem, we're going to multiply the square root of 5 times a binomial, which means I have to multiply the square root of 5 times each term. So remember, when you don't have a coefficient in front, you have a 1. So I have 1 times 4 is 4, and then the square root of 5 times 4 gives me, then the square root of 5. So that's this term times that term. Then I have 1 times negative 1, and then 5 times the square root of 20, which is the square root of 100. And then to simplify, I'm just going to bring down the 4 radical 5 because I cannot simplify it anymore, but I do know that the square root of 100 is 10. So I can't combine these terms together because they're not alike, but that is my simplest form and my answer. On number 6, I have two binomials that I'm going to multiply together. This binomial times that binomial, so you can remember from our polynomial section that you can FOIL. You could also use the box method if you prefer, but I'm going to show you foiling. So I'm going to do the first term times the first term, which would give me the square root of 36. Then I would take the outer terms, so the square root of 6 times the square root of 2, and that's a minus sign in front, so a negative radical 12. And then I would do the two inner terms together, and they're both positive, so I'd get positive radical 12. And then I do the last terms together, so I'd get radical 4, and you're subtracting, so you have a positive times a negative, so you have a negative radical 4. Now I can simplify. First, I know that this is the square root of 36 is 6, and you can see if you have a negative radical 12 and a positive radical 12, they cancel, and then subtracting the square root of 4, which is 2. So this whole thing is the same thing as 4, and that would be my answer. All right, we have 4 more problems. Okay, again, I have two binomials being multiplied together, so I am going to FOIL again. So I'm going to multiply 2 radical 3 times radical 10. I multiply the coefficients together and I get 2. Multiply the radicands together and I get 30. Then I'm going to multiply the outer terms together, so 2 radical 3 times 4 radical 6. So 2 times 4, that makes 8. And then 3 times 16 is 18. 3 times 6 is 18, not 16. Then I do the inner two terms together, so I'd have a negative times a positive makes a negative. 5 times 10 is 50. And then I have the last two to multiply. So negative 1 times positive 4 is negative 4, and then 5 times 6 is radical 30. Now I have to simplify within each one. Okay, I cannot simplify 30. There's no, if you think of your square roots, your perfect squares, you have 1, 4, then you have 9, then you have 16, and then you have 25. None of these are factors of 30. So I'm just going to combine the two 30s that I have. So I have 2 radical 30 minus 4 radical 30. 2 minus 4 is negative 2 radical 30. So that's taking care of that. So these are taken care of. Now I'm going to look at 18. And 18, so I have 8, and then I have this, which breaks down into 9 times 2. And I know that the square root of 9 is 3. So I'm going to take a 3 and multiply it times 8. 3 times 8 is 24. And then I still have a radical 2 right here. Okay, now so I've taken care of that. Now I have minus radical 50. Well, radical 50 breaks down into radical 25 times 2. So then I can take the square root of 25, which is 5, and put it in front. So minus 5. And then I have the radical 2 still inside. And now I can combine like terms. So I'm going to combine 24 minus 5 radical 2. So 24 minus 5 would give me 19 radical 2. And again, I have in front negative 2 radical 30. And since this is positive, I put a plus sign. So negative 2 radical 30 plus 19 radical 2 would be my answer. Okay, well that was a fun one. I enjoyed that one. A little more challenging. All right, let's go to the next page. Okay, so here I have a binomial that is being squared. So I can't just put the 2, I can't just put the 2's there. That doesn't work. So what I have to do is rewrite this as a product of two binomials. So I take radical 3 plus 2 radical 2, and I'm going to multiply it by itself. Radical 3 plus 2 radical 2. Now I'm going to FOIL again, so I'm going to multiply radical 3 times radical 3. That gives me radical 9. So then I do, remember it's FOIL. So that was the first terms. Now I'm going to do the outer terms. So the coefficient is 1. 1 times 2 is 2. Radical 3 times radical 2 is radical 6. Then I'm going to do the inside terms. So then I also have 2 times radical 6. Then I'm going to do the last terms together. So I would get 2 times 2, which makes 4, and radical 2 times radical 2 makes radical 4. Now I can simplify this a little further. So radical 9, we can take the square root of 9 as 3. We can add these two together because they are like terms. So 2 plus 2 makes 4 radical 6. And then here I can take the square root of 4, which is 2, and multiply those two together to get 8. Now I can simplify again because I can combine like terms here. So I'd get 11 plus 4 radical 6. And that's going to be my answer. All right, last two. All right, number 9. You can see that you've got an exponent on the outside of this monomial term. So I'm going to take this monomial term and rewrite it because I'm going to multiply 2 radical 5 times itself. 2 radical 5. So I'm squaring each term inside. So 2 times 2, that makes 4. Radical 5 times radical 5 is radical 25. Well, I know that that's a perfect square, which is 5. So I do 4 times 5, which is 20. Well, that's a nice, easy answer. All right, now we're going to take the last problem that we have is a monomial times a monomial. So what we're going to do is multiply the numbers on the outside, the coefficients. So I would get negative 8a, and then I'm going to multiply the radicands together. So inside the radicand I would have 8 times 50, which I think is 400. And then I'd have the a cubed and b to the 100th. All right, so now I need to take and break this down and simplify it. So negative 8a stays there. I'm going to take the square root of 400, the square root of a cubed, and the square root of b to the 100. All right, I know that 400 is also 4 times 100, and both of those are perfect squares. So it must be, this must be a perfect square, and I think it is. It is 20. So this is negative 8a times 20. The square root of 400 is 20. And then a cubed, I can't take this, it's not a perfect square, so I have to break it down. So I have the square root of a squared, which is a, and then this a would stay inside the radical. And then b to the 100, well, that is an even exponent. And I'm not going to take the square root of 100. I'm taking the square root of b to the 100, which means I divide the exponent by 2. So the square root of that would be b to the 50. Now I'm just going to come over here and put everything together. So negative 8 times 20 would be negative 160. And then I have an a times this a. These two a's multiplied together would be a squared. Then I have b to the 50. And then inside the radical I have radical a. So there would be my answer. So be careful with this that you don't put b to the 10, because that would be a common mistake that I can see people making. All right, I believe we're done and we're ready for homework.